All right, so let's talk about MongoDB. So this is the the fourth element in the mean stack that we introduced a couple of weeks ago, where we first talked about Angular as being the A in mean, which is the front end part of the stack. We then talked about Node.js and Express as being the N and the E in the mean stack, and those were part of the implementing the middle tier part of an application, right? The ones that is responsible for receiving HTTP requests, such as put, get, delete, and manipulating some kind of data model. And so Mongo is the fourth in the mean stack. It's the M in the mean stack, and it's one of many new databases that fall under the umbrella of non-relational databases. So these are alternative databases to the legacy or the typical types of databases that have been around with us for a while. MySQL, SQL Server, Oracle. These are all mostly relational databases where they use tables and records and rows to model the data and structuring the data using foreign keys and primary keys to create complex data structures. Non-relational databases, it's like the name suggests. It doesn't use relationships. It doesn't use foreign keys, primary keys. It doesn't break up the application, the data structure, in terms of records that are somehow related to one another by foreign keys, primary keys. Instead, they might use some other ways of capturing that, either using a hierarchy or some other way of capturing the relationships. We're going to be looking at, in particular, the Mongo database. I mean, there's plenty of other non-relational databases, Dynamo, Cassandra, Couch. These are all non-relational databases in that, again, doesn't use tables, doesn't use records, doesn't use foreign keys, primary keys to create the structure. Instead, they might use XML, they might use JSON, they might use some other means of capturing the relationship between data. Right? The reason we're using relational databases is that we try to normalize the data. We look at some data that has a particular structure, usually has some kind of hierarchy or some graph representation of the data where multiple entities are somehow related to other types of entities. And the way we capture that structure is by representing each type of entity in tables, and then relating them by having records have foreign keys that reference other records in the primary keys in some other records. Here we're not going to do that. I mean, there's plenty other alternative ways of capturing data. There's graph databases, there's real-time databases, each one designed to solve a specific problem for that particular domain. In non-relational databases, in particular Mongo, it's a new breed of databases that is trying to solve a new type of problem that was introduced with the huge amounts of data that we're generating daily in web applications, where most of the data that is being generated is in some form of JSON, a lot of this data is unstructured. We don't really know what the structure is. We know some fields and data that is being generated every time we move our move our phones around and we drive around. We're generating huge amounts of streams of data every time we visit a website, or a lot of this information is unstructured, and only at post-processing can we perhaps identify relationships about this stream of data that is somehow related to this other stream of data, and we realize that it's you. That we're visiting Best Buy, and then we're visiting Whole Foods, and you're visiting this other website, and somehow we triangulate and realize that it's you, right? And we try to relate all these different streams of data and create a profile that might describe you as a customer, as a potential customer, and then we try to sell that information off to the highest bidder. So a lot of this data is unstructured. We don't know what the structure is, and we discover the structure at post-processing. And again, it's huge amounts of data. A lot of this data might be geographically distributed, right? And that might be relevant to a particular geographic area, and some other data that might be relevant to some other geographic area where it's the same database, but with structure or broken up into multiple regions that might be targeting certain locations. Also, these databases typically are fairly redundant. Perhaps a lot of the data is being captured multiple times, and we don't even know it. Whereas in a relational database, we make all the efforts, a lot of effort at making sure we don't have any redundancy in our data. That we want to make sure that we don't risk inconsistency. That if you do a query one way and you do the same query that logically should give you the same answer, somehow it's not the same answer. That would be an inconsistency, right? And we try to weed out all those inconsistencies early on. Whereas here, we don't even know that certain streams of data might even be related, right? And we only identify redundancy later on, and we might restructure the data to weed out all this redundancy at a later time. So a lot of new requirements need new solutions, right? And Mongo and many other of these other databases are stepping in to try and fill this new need, right? We're generating more data today than we could ever possibly consume. So we need new automated systems that can process this data automatically and extract patterns and extract data, right? That might be then useful for us for consumption, right? So it's not meant for an individual making a query here and there, right? It's meant for some of these AI and a lot of these processes to reduce this data into useful chunks of wisdom. So we'll be using Mongo. There's plenty of other alternatives, but we're going to be focusing on MongoDB. So you can install MongoDB by going to mongodb.com. They'll try to sell you a paid-for version of Mongo, but there's a free version. There's a community version of Mongo, and encourage you to go visit the community URL here, and you can download and install it on your machine. When you install it, the database is going to ask you that it'll need a couple of very simple configuration. One of them is that it's going to need a file, a directory where it can store the databases that it's going to create for you. And typically, the default place for the location of your data files is under this directory, /data/db. You might need admin privileges to create that directory, so do that. You can change the location if you want, but this is the default, right? So if you start the database without this directory, it'll complain. So when you install it, it creates a bin directory. In the bin directory, there's quite a few executables, two of which are of interest to us. One of them is mongod. Mongod is the actual server, the database server. It's a daemon that starts the server, and it listens at a particular port, 27017, I believe, and it'll check to see if that directory exists. If it doesn't exist, it'll complain. You might need to be an admin to start mongod. I think on Windows you don't need to. Obviously, for this to work, you would put all the bin directory in your path. Make sure you have the bin directory in your path so you can execute these commands from the command line from anywhere. All right, so that's the server. When you start up, it might look something like this. The other command that's of interest, it's the client, right? That allows you to communicate and interact with the server, and that's started with using Mongo. Mongo again is that second executable of interest. It'll connect to your local host 127.0.0.1, and at the where you have your Mongo database running by default. Again, you can change. You can also provide here as an argument to connect to a remote Mongo database. If you have it running maybe on MLab or some other remote server, if you provide the URL or the IP address of where the Mongo server is running, you can connect to the remote client, a remote server, and interact with the remote database. A couple of commands, useful commands. Again, we're only going to skim the surface, right? The minimum you would need to be minimally proficient in Mongo. Certainly, you could have a whole course just on Mongo. So show DBs allows you to list the databases that are currently local to your database. And in this discussion of Mongo, we're going to be using the following data model all throughout the examples that we're going to be using. So it'll be a user. This will give us a chance to play around with a base class and a couple of inherited classes, faculty and student inheriting from user. We'll have a chance to play around with a couple of one-to-many relationships between a faculty having authored many courses or faculty teaching several sections. It also gives us a chance to play around with a many-to-many between student and section. This will be an association class, so not only it'll be a many-to-many, but it'll also have some fields here, right? So it'll have to have its own table or its own collection. So this will give us a chance to play around with some of these concepts and how you would model them in a non-relational database such as Mongo. Creating a database. So creating a database is as easy as just switching to the database. You say just use the name of the database and done. The database is created. It'll switch there. Once you're there, you can start interacting with the database, creating new. You can start inserting. A couple of jargon. Instead of tables like we use in relational databases, in Mongo we say they're collections, right? So it's a collection, and it's not a collection of records. We say it's a collection of documents, right? But they play the same role, right? Collections are just like tables, right? They're a set of data points, right? And instead of records, we say they're documents, right? All the commands have this syntax where they all start with db dot, then the collection you want to work on, right? Or the table or the collection you're working on, and then the command that you want to use, where the command can either be, I want to be able to insert, I want to be able to find things, retrieve data, update existing data, or remove data. All these commands take a command or an argument in the argument list, which is optional depending on the command. Okay. To insert data, it's as easy as saying db, the collection that you want to insert into, and then the dot insert. Notice that nowhere do we define the structure of the data. Typically, in a relational database, you would first define the structure of the data by creating a table, saying, listing all the fields, saying what the data types are for each one of those fields. Here, there's no such thing. There's no schema. For those of us that come from relational database, we should cringe at that there's no schema. But again, that's not the point of Mongo. It's typically what a schema is for is so that we can validate that the data that we're inserting or the data that we're updating, that it's following a particular structure, right? That we are inserting data of the particular data types, correct data types. So we're typically we have the database validate the data that we are manipulating. So here we're removing that responsibility. We're not going to have the databases have that responsibility. It's not going to be the database's responsibility to validate that you're inserting bad data or good data. Instead, we're going to move the responsibility over to the application layer. Right? The application is going to be responsible to make sure that what it's inserting is correct. Right? It's not going to be the database's responsibility anymore. Same thing with any validation of any constraints that we might have, of whether this has a particular pattern, or whether it's a number or floating point or a date or anything like that, right? All that is going to be moved over to the application side. The application will be, and that's fine. I mean, typically you already have a data model at the application layer anyway, right? You already have a class. You already have some means of validating that the data is good, right? And it would have been nice to have the database revalidate that the data is being inserted. But there's no structure. It has no schema. Even as you might misspell the name of a field, and that's fine. The database doesn't care. Some documents will have 3 fields, some 4 fields, some 6 fields. Doesn't matter. The spelling doesn't matter. The data type's value doesn't matter. Again, all that responsibility will be for the application. So here's a particular document with a name and age with different data types of strings and numbers. Notice that some fields, so these fields are using primitive data types, right? Just strings, numbers, dates. But you can combine them to create even more complex data structures where a particular field is not just a primitive data type, but a combination of data types. It could be this might be another object, an embedded object, which contains arrays of objects of arrays, as complex as you want, right? So in that sense, Mongo should be considered to be an object database, right? A database where you can store object instances, right? As opposed to records. They're not really records. They're object instances. So at some point, these objects existed in memory, right? And you're just storing it permanently in a database for later retrieval, right? Kind of like what you might do if you have a Java instance object and you would serialize it to a file, right? For later, reinstantiating that object from a file into memory, right? And what Mongo does is that it allows you to store JSON objects and then query. So you could retrieve the objects that you want out of the thousands or millions of objects that you might have stored. He says, well, I want only those 1,000 objects that meet this criteria, right? That have these employees that were, whose the data of employment was so and so date, and are making so and so salary within a particular range, right? So you can retrieve those instances that meet a particular criteria. And these documents are going to be stored, multiple instances in a collection of these objects or documents, right? That have their own state, their own information, their own particular values for those objects. Once you have inserted documents into a collection, you can then retrieve them. You can say, show me the list of collections, and then it just displays the list of collections. You can retrieve a particular object, right? And so insert to add data, and to retrieve data, you can say db.user.find. So again, db. The name of the collection, .find to retrieve all the objects. So find is very much like a select, okay? And by default, find will return all the fields, all the records, all the documents, just like you would do select star from and then the name of the table with no where clause, right? It would come back with presumably all the rows in the table, right? So this would return all the documents in the collection. Here you have an optional parameter that you can pass here. If you want to filter out and say, well, I don't want all of them, I only want the ones that match a particular criteria, you can provide the criteria as an argument there. All right. So actually, let's do a demo. Let's play around with an actual database.